Good evening or good morning, wherever you are, whatever time it is. Hope it's a good one. So today I'm here to talk about Katana. We've got this fancy little title, Power in the Pipeline, Freedom for the Artist, but really we do believe that. And what we're hoping you take away from today is understanding what kind of companies are using it and what they're using it for. We'll go through some of the fundamental little building blocks, the tools, the workflows that make it a powerful option. And then we'll piece one of those together into an overall flow so you understand how all those different pieces come together. Okay. So, for those of you who haven't met me, I'm Jordan Thistlewood. I'm the Senior Product Manager for Look Development and Lighting here at the Foundry. And let's jump right into it. So, what do we got here? These are 3 upcoming feature films where the visual effects work is being done with Katana by one or more clients. Here we have a range of films that have been done in the past. Pixar, using Katana with RenderMan 21 and USD. 3 killer tools that come together and provide some pretty awesome power. So if you saw Finding Dory, you saw the first film that was lit from start to finish using Katana. And all the upcoming feature films are going to be that way as well. Then we have companies like Atomic Fiction. These guys are smart and like working that way. And so, we had a small team working on things like The Walk, Deadpool, and Star Trek Beyond. So their work does not truly show the size of the team. They do fantastic work, but do so efficiently. Then we have groups like Micros Image, we have Leica, and then we have the team over at Light Chaser in Beijing. These guys all do fantastic work in the full CG side. Leica's case, obviously, it's the CG that they're doing for their stop motion, but it's a different mix of work, different style of pipeline, but Katana fits in there as well. And then we have smaller visual effects teams doing everything from TED 2 at Tippett, London Has Fallen at Worldwide Effects, and then the guys over at Allura working on Mad Max. So again, it's not the size of the team, it's your desire and need to work efficiently that determines whether or not Katana is a fit for you. Okay, just a little cross section of the companies working on Katana. Okay, so let's get into talking more directly. We've got a guy here who really illustrates the principle of what we're talking about, look development and lighting. So Katana takes over from when you've got your modeled form, you've made your color decisions, and you want something to come out in your shot looking the way you want it to. After look development comes shot lighting, but really what we wanted to talk about is the creative lighting. So we all know lighting is a long, complex, technical process. But at the end of the day, that is all there with one purpose in mind, which is creative storytelling through light. You want something to fit into the frame if it's visual effects, but you also want it to support the cinematography. If you're doing full CG, you have the full range of digital cinematography at your fingertips, and you are there to create the story through that light. So how does Katana work on that? Well, there's fundamental problems of time. So Katana loads big data fast. That's pretty much, if there was one tagline to it, it is that fundamental piece. Those of you who wait 10, 20, 30 minutes for big 3D scene files to load, those load much faster in Katana. On the top right, what we have there is the representation of the multiple teams that come together on a CG production. Each of them has to contribute their part, but in the end, most of it has to go out through a render engine. So if it's going to go out through some kind of renderer, it will typically be funneled together inside of Katana. So Katana not only provides the ability to funnel all this together, it provides the ability for multiple teams, animators, and TDs to feed a lighting department. In the bottom right, you've got a team of lighters. Lighters who all have to work together, have to share their resources. You might have a lead feeding junior lighting artists. You might have a lighting supervisor working with their leads. it's all about the sharing of information and setups. If you can't do that efficiently, then you are working with one hand tied behind your back. So the same kind of ideas of communication and sharing of setups that happen for the teams also mean that within the lighting department, groups can be sharing information. And finally, Katana replaces a big chunk of the pipeline around the idea of pre-cached asset-based workflows. So this idea that you finish a model, to get it ready for the render pipeline, you've got to make it into a RIB file for delayed read archive purposes, an RLD scene source file, or a VR scene file. A lot of that work has been serving the industry so well for a number of years, but it does have its limitations in terms of how can you interact with that in the shop pipeline, and how easy is it to make those changes? How do you deal with variations? All these things that pop up when you are in the middle of shop production and your deadline is bearing down on you, and you just have to make the changes quickly. So Katana provides a much more flexible pipeline, and that's why we're happy about making those options disappear for people if needed. Okay, so very quickly, where does Katana fit in the overall pipeline of steps? It is in the look development and lighting. All right, so in those two departments, it could be the same person doing the work. It could be different people handing things off to each other. And the way Katana does that is that there's a special file format that we'll talk about later called the Katana look file that allows you to trade information between the look development and the lighting department. And again, it's all done in a way where everybody can kind of carry on with their work in a non-destructive fashion. The overall flow of technology or workflow is that your main 3D applications all export either a USD file or some other form of scene description. You use Alembic, USDC, or the multiverse version of Alembic, and for the actual geometry caches, those can be fed to Mari, so you can do your texture painting, which provides the texture maps. All that comes together inside of Katana. Now, currently we have a 3Delight, Arnold, RenderMan, and V-Ray plugin. Redshift guys are definitely working on one, and we're excited to see that one coming out when they're all done. There are two commercially supported render farms. Now, we support everything that can issue a command line, but in terms of low to no setup, you have Deadline, version 8 and higher, and then Pipeline FX Cube, version 6.3 and higher. And of course, so the flow is from your 3D app, geometry, Katana, to the render farm, to your compositing. Okay, so what I want to do here is play a little animated short for you so we can discuss some of the philosophies of how Katana can work in terms of this multi-shot context that we get a lot of questions about. And so the history on this one is our illustrious Brad Peebler had a great podcast, and he was always very enthusiastic. And in that enthusiasm, he had one person write him and say that, okay, you know what, dude, you're a little over the top. Can you tone it down? And this was their response.
There was a Moto user who finds our antics to be somewhat disconcerting.
Oh, really?
Yes. So I think in the interest of saving our show, David,
we need to
bring it down. And so, this week on Modcast, we'll be talking about 701 sneak peeks.
Yes. Let us discuss recently the Moto 701 sneak videos that we've been posting on our YouTube playlist.
David, I gotta tell you,
and Indirect Connect.
I'm very excited about the videos we've been posting.
I think the videos elaborate on our ideals as a company and what we like to project to our user base.
Yes, I hope I can convey my excitement to the community about these videos.
Whoa, Brad. Tone it.
Bring it down. I apologize.
So
I can't do this anymore.
it's like you cannot cage the beast.
No.
Okay, so we've seen that little short. It could be a commercial unto itself in terms of the length. It could be a small section of a sequence in a TV show, animated film, however you want to look at it. It's a small chunk of work, but it has all the right ideas that go with it, which is you have the ability to group it by hierarchy because there's a lot of overlapping labor, and that is your opportunity for efficiency. So looking at this chart, we've got the one wide shot at the top. Now you could call this master, you could call it a key shot. People use different terms. It's master, key shot, sub shot, key shot, sub shot, or parent, child, sub child. There's many ways, and depending on where you're at, you can work with whatever name structure you want. But the fundamental idea is that Katana allows you to make the choices in this master shot at the top. You can choose the layering, you can choose the look development, you can choose the lighting, you can choose the passes, you can choose the masking and the matting. You can get all of that sorted out on that one wide shot. Katana will allow you then to share that setup down to the series of shots that we see in the orange. So call them child shots, parent shots, however you want to look at it. These shots have a degree of work to them. They can inherit from the master shot. They have some tweaks that they need to have done. Maybe it's the rim lights need to be changed based on the camera angle. Maybe certain objects need to be turned on or off. Maybe lighting just needs a bit of a creative polish based on the camera angle beyond just the rim lights. Any which way you look at it, that work is something that needs a lighting artist to do. Then you get down to the layer of the green shots. The green shots are the ones that don't necessarily have any new challenges. The creative solution should already be in place. If someone upstream in the pipeline hasn't cheated on the layout, there really isn't much left that you need the unique abilities of a lighting artist to tackle. So if you had an automated pipeline that could make those go away, a lot of people would be very happy. So let's take a look at it a little bit differently. We've got one red shot, so master, sequence, level shot, whatever you want to call it, and you've got 7 key shots. So it means you've got 8 shots there that a lighting artist definitely needs to touch out of 21, which means that there's 13 shots, over 60%, that in a perfect world a lighting artist would not touch. If you could just actually automate those to the farm and maybe patch things up here or there if it went awry, you've got some pretty compelling options. You can say the same group of people stretch out their work over a longer period of time against those 8 shots, improve the quality, and spread that out over the whole project. You could take the team and you could divide them up. You can be working on multiple sequences at the same time or multiple projects. Or you can take the same team and just plow through it a whole lot faster. So you've got a lot of freedom, both as an artist and as a business, for how you process and deal with your rendering. So we've got all this pretty sort of wide options. Now I wanted to address one comment that always comes up. Yes, this is heavily based on the efficiency that you can achieve with with animation. Visual effects still benefits from a lot of the key factors that we'll talk about next, but it is indeed project by project based on how much templates and inheritance and those things will benefit to the same level. But more often than not, there is some element of reuse and sharing and collaboration that Katana powers in a visual effects project that will give you a corresponding boost in productivity. It's just not, it's more project by project than it would be with a full CG animation. Okay, so as we start to dive into the little examples and we'll run through the UI, what I'd like to do is have you think about these things. These are the kind of things that we will actually now go look at. So everything in Katana is a reference unless it's a primitive made inside of Katana. The node graphs function as templates, meaning that you can put in new inputs at the top and get out similarly processed different results at the bottom. there is an element to work being procedural and hierarchical, meaning that you can branch and fork and basically flow your way through a node graph that allows you to create multiple scenarios at different points, which just comes in handy for things like running multiple shots through the same node graph. The node graphs can also be driven by rules. So this is what we'll talk about when you hear me talk about CEL, or collection expression language. The rules that are in the tools allow you to create node graphs that are far-reaching, have much higher elements of reuse, and provide a lot more power for the chaotic changes that we all know happen in production. So if a node can be driven by a rule, it might have the ability to accommodate change, which is pretty cool. And then finally, we'll look at a layer of artist interaction that is all about the lighting workflow, the rendering of the artist in an interactive session that does not pollute what happens on the render farm. This is pretty big. If we've all been in a situation where we've accidentally turned off an object because we didn't want to see it to make our interactive renders faster. We were debugging something. We save that file, we submit it to the farm, and it comes back wrong, and we're all explaining it to our supervisors. Now, a lot of companies have put in measures to try and stop this, but it's fundamentally built with inside of Katana, like many things, like the ability to even do shader libraries. So without further ado, let's actually go take a look at the UI. Okay, so now that we're in the UI, let's take a look at a few different aspects of what's going on here. It's slightly different layout in terms of what panel goes where than the sort of default starting point, but I'll show you that in a minute. So first off, we've got this little Python shelf. I'm just going to set the location of the project I want to work on, and I am going to come in then and find that file. So I don't know if you were sort of consciously looking at it, but that's how fast it loaded this scene. So we'll just jump down to the bottom and kick off a render real quick. Because what I want to emphasize right now is that point that I was making earlier, which is Katana opens big files fast and gets you into them. So I've spent more time talking so far than it took to load the file. And the big significance of all this is that as you work on various projects, you sometimes have tasks, things assigned to you that are going to take a fraction of the time it takes to load the file. And that is a bad ratio to have. If it takes you longer and you're waiting more time than you're working on the file, that's a bad place to be. So we're very happy that Katana provides an option that gets us around that problem. Okay, so this is the scene that we're going to be working with right now. So this Katana project file opens quickly and gives you the option to work with this pretty fast. So I'm not going to force it to resolve all that. So what we end up with is we have the node graph. So when Katana loads, this is what is the primary entity that is getting loaded first. All right, so we have 3 cameras that are being loaded by Alembic. We have various parts of that city scene that are then also loaded. We have various prototypes that are loaded for the instant scene. We have the instant scene setup. We have a node that allows us to make changes to how the assets get their shaders. We have a block of work that is set out to do the lighting. We'll talk about that in a minute. Your render file, your render outputs are defined by nodes, as well as your render globals. And I'll take this moment to point out that the render plugins, so in this case Arnold, have a whole series of nodes that are their own. In this case, here's Arnold's ones, that divide the work into what is the tool specifically for the render plugin, and what is the tools that we provide as Katana nodes. Okay. So render settings versus the render globals, difference being this is resolution, which camera, which render, and this is all the things that make Arnold function as Arnold. Okay. So that's the node graph. The node graph, then, depending on which node you look at, and by look, I mean, if we come down over here, we can see that we have this node selected with the blue dot and with the green dot. It means the green dot is telling us that this is the node whose parameters we want to edit, and the blue dot is saying, hey, make me the 3D scene. So every node essentially has its own 3D scene. You could look at it that way, all right? So the 3D scene at this node just happens to be this camera. If we pan across here to this merge node, and we just give it a sec, boom, we start getting more 3D geometry. But you'll notice in the viewer down here, we actually haven't started exposing everything. So we've got the ability to get in, start interacting with the node graph, have an image faster than you typically are dealing with a large file when you're working with another application out there. Okay. So that's all fine and dandy. So when do you start to see things? Okay, you will start to see them as you work your way through the hierarchy. Now, this is one way to do it. So we can see that we just started getting bounding boxes here. Now, depending on what you need as an artist, you don't necessarily need all the details. I mean, the ultimate goal is you want to work on the image. So we do have one layer of interaction. So in the Pixel Probe, you'll notice right here that I have the ability to pick through the scene and find out what's underneath each pixel. For the interactive renders, we ask it to provide an ID pass. That ID pass then allows us to actually say, all right, well, I want to work on that object. So instead of having to hunt my way through the hierarchy, I can very simply just pick from the rendered image and then find my way to that particular object. Now, if I come down farther, so we have a more interesting 3D scene to interact with, we can see here that we found that one particular roof. If I come up here, pick another one, again, I can find it. So the general philosophy is don't interact with everything heavy if you don't have to. Keep it nimble, and you can work your way through it all. All right, so the node graph, by control of the parameters, makes the scene graph, which is shown in the renders or in the viewer. Right, so we've kind of got everything we need to know about that part. Now we start getting into interesting parts like we were talking about with the short animation. So how can someone run multiple shots? Well, this is the beginning block of that. We have 3 cameras plugged into a switch node. More accurately, something called a variable switch node. The variable switch node, if we look at its parameters, is looking for a variable by the name of shot, and it has 3 inputs, which match the 3 inputs on the node itself. Now, what this actually means is that we have the ability to define an environment variable or a variable within the shot. Now, we call these graph state variables, but they're like an environment variable you would use in setting up your facility. So you can make these, add them to your scene or to your project file, and you can see now I've got a new one up here. So var A, it's the only option, but with the shots I've got 10, 20, and 30. So what it means here is that I've got 3 different cameras that feed to a variable switch that's controlled by this control panel up here. That means that I can look at 3 different cameras that will process through this whole node graph. Okay, so all the way through, and then we hit to this point. We've got another variable switch, and what that is doing is interfacing with the lighting. Okay, so anywhere where we are horizontal, we're starting to merge things together, but we've got options for branching. In this case, we're branching and bringing it together. Here we fork and come back together in the variable switch. What does all this mean? Okay. Well, first off, we have lighting that is being brought in from outside. Katana has one internal referencing system that is like a Maya file reference. It's called the live group. This is where you can take a set of nodes, you can group them together, and then you can publish it to disk, and you can then share that. So in this case, someone else established the lighting through this Gaffer 3, which is our low lighting control panel, and saved it out. And then this file here reads it in. Okay? So with that in mind, we have the lighting now added to the scene. So this would be like our sequence lighting. And we have 3 of these lighting control panels that are set up that inherit from this master lighting. Okay, so we've got 10, we've got 20, and we have 30. So depending on where this variable switch is set, based on this, we get different results. So let's actually put this into practice and have a look. All right, so I'm going to launch a live render. While it's doing that, I will just pop back up to our lighting section. Okay, so we have an IPR like render on the go. We call it live render. And we have the option to start discussing some of those layers that are about the artist interaction with the scene. Okay, so here we see we've got a whole bunch of things in the viewer. We've got 3 columns here. What we have now are the working sets. So if I turn this one on, you'll see that everything in the viewer disappears. What does that mean? This is a artist only, interactive only list of objects that you would want to show. Okay, so you can turn on and off the visibility of something in the viewport simply by picking from this list of objects. And this can be saved out to disk, so if you have to reuse this again and again and you want to share it between artists, you can. Okay, so we'll turn that one off. We have a similar control. This one here controls what is actually an active visible object in the interactive render. You want to make half the city disappear, you turn this one on, and then objects start disappearing, and you can control which one. But it doesn't matter. When you send it to the farm, it's fine. So again, you've got a layer that is for you, the artist, that is different from the pipeline. So everybody kind of gets what they need. And then finally, most relevant to what we're going to be looking at is this one here. We have the controls for live render updates. Okay, so I am going to come in and turn on lighting. I am then going to come over here and I'm going to say for a second here, let's say that we've show you this. So this is what happens. So the Gaffer 3 is in this node here being referenced from a file. It's now feeding lighting information through the scene. I have this node here where I can say that I want to show the incoming lights. They're dimmed out. You can't do much with them, but you can say that you want to adopt them for editing. So what does this mean? It means I can now come in and kick the intensity. I can make this bigger if I want to. Let's just make this bright. Not saying that this is what an art director would approve, but it's pretty obvious what we've done. Okay. If I now come to the graph state variable and switch it, I get the new camera, I get the lighting that's coming from here. Now, because we haven't actually made a change here, I'm picking up the lighting that came from there. So the lighting flows through. Important thing to take away from this. The changes that you capture when you are making these edits to the lighting that's already in the scene is that it's on a parameter by parameter basis. So I've only changed the intensity so everything flows through. So I can now say that I wanted to add a new Gaffer 3 node. And I can add it right here. because let's say that I need to make a change across the whole sequence. Okay, so I can say I want to show the incoming scene lights. I want to say that the sunlight is not warm enough, so I can change that. And there we go. So what have I done? I have now inserted into the chain of nodes an override that is going to change the color that will then feed to all three of these shots. I can come look at shot 10 and see that I've also passed on that change, but it's also picked up the intensity. Now, the flexibility of the Gaffer 3 in this situation also extends to the point where these are inherited lights, but it doesn't mean that I can't add my own lights at any level. So here I added them at this level. Now if I come in here, I just need to refresh that. You can see that I have those new lights. So I have lights that were loaded from a reference file, modified, added new lights here, modified the intensity of one of those lights here. So you've got this, again, this hierarchical, procedural way to manage the lighting, specifically, in this case of the Gaffer 3, of multiple shots within one sequence from one project file. Now, if I started actually putting other nodes that affected geometry or ray settings and things like that underneath this one before it fed into the variable switch, I can make whole massive changes. I can change the configuration, the layout, you name it, all before on a shot-by-shot basis. But if there's something fundamental that changes with this setup by art direction that comes from an external department, could be a new layout, things like that, all those changes are going to be preserved. Okay, so I can get a new layout that has 50 new houses of a different third, fourth, fifth, sixth type, and I don't care because of the way that this is all set up. Okay, all right, so we've got that part covered. Now let's take a step back up for a second. We have something called the Katana look file. We mentioned it earlier. So what's happening here? We have, in this case, the ground object referencing this look file. It means that the shaders and everything else about this file, about this ground, apart from its geometry, come from this separate file. It's fundamental that you understand that you can separate the look defining data from the physical form data, be it so your models are separate from your shaders and the texture map descriptions. It means that they can be independently updated. It means that you no longer have to carry the shaders on the rig. It means you have full flexibility to embrace a geometry caching pipeline if you haven't already. And it gives you great flexibility because you can have one model that is then used with multiple looks, and it's as simple as changing the look file to get the different look for that model. Okay, what I'd like to do is take a moment and take a step back in time. So this is the shot file. We've brought it all together. We've lit it. We've been able to show that you can have multiple lights or different shots within this. Let's take a look at how this all comes together, and then we'll start looking at some of the more nitty-gritty basics of what's going on so you understand from a different perspective. Okay. Okay, so in this file, we've got two things I'd like to illustrate. One, how we can make a shader library, and then in a separate file, I'm going to show you a bit more about the inheritance that comes with Katana's sort of material abilities. And then we also have, beyond the shader library, the look development of all the buildings for that last scene that we were looking at. And finally, we have the end game, which is let's take the models, separate them from their look development, and write out what it takes to do all that look development to a separate file. Okay. So first, let's start with this idea of a shader library. Some of you probably have some semblance of a shader library already. Maybe you don't. So Katana happily can provide you a leg up in the department. So what we're looking at right now are the shading nodes. These bottom three are called the network materials. They are like the Maya shading graph or shading group nodes. They are the ones that maintain the connection to the 3D scene. So if I look at the scene graph for this section here, what we'll note is that there's only those three nodes, 1, 2, and 3. The rest of the shading information does not appear in the actual 3D scene. So what we have is a Lambert and 2 Arnold standard shaders that are plugged into these network materials. The Lambert and one of the standard have an image map plugged in for the diffuse. Very basic, but it'll help us illustrate the point. Okay, so each of these has its own set of parameters that we would interact with and control. But when we get to here, we can start to see things like we have this little part where it says image out. So it's saying that the connection for that channel is driven by this image out. Now, what it gets more interesting is that you can see this control here for the KD on the standard shader. It says appears as KD. What it means is that this network material allows you to define what is the actual control structure you want to pass on to an artist. So you can have both a network material workflow that you present the controls or a refined set of controls in the same fashion as if you had an Uber shader model where you were doing a lot of the coding under the hood, but you wanted to create a monolithic shader that has a controlled set of parameters that an artist can tweak. So in other words, you can create a metal and then you can pare down the controls that are visible to an artist to be color and roughness if you wanted to. You can do all kinds of crazy networks and make it very simple so that you can have reusable assets in your pipeline. So something along the lines of coming in here and just saying that you want to edit this, and you could say make this roughness, and now that will show up in the interface appropriately as roughness. Right. So all this comes out to this point where we have this node that allows you to write out all that shading work to a file, which you can then treat like a shader library. I can take this work and I can make it disappear. So let's delete this material. And on the corresponding node here, we have a look files material in, which will now read that file that we had baked out, read it as a reference or not, and it loads into the node graph those materials we created. Okay, so here's the material, but here's the cool thing. The full node network is still captured. So you may have made a refined set of controls, but you still have access to all that data. So even though it's not physically in the file as a series of nodes, the data that constructs those nodes is, and therefore you have access to it through various tools in Katana. So we'll cover that on a different webinar, but just wanted to make sure that that idea of the data is always there is present in your mind. Okay, so let's take a look at what we've got in the scene very quickly. Right, so we've got our full set of 3D models from that building scene, right? So we're going to work on these all at once, which gives us a great opportunity to talk about rules and things like that. Okay, so we've made a shader library, we've set up some basics, we've passed it through. I want to cover this in more detail later, but what I do want to look at right now is this idea of materials, and this stack node that we're looking at is simply a node that contains a like set of nodes. So in this case, the material node, which is how we create materials within Katana. So what's happening here, though, is we are making a child material. So we are taking that Arnold standard shader with the texture map. We're making a child called walls. And then you can see that we've got a refined set of controls that we added through. Okay, so these are the ones that we pre-populated. So instead of having every single dial and parameter, we have a small subset. Anything that is being changed shows up as yellow, which means that we know what's overridden, and everything else that is not would inherit from its parent. So if the parent gets changed, the child will change. All right, so we do that across multiple surfaces to make everything we need for the scene. And then we move down a bit. Now, we talked about cell a bit. What I'm really stoked about is the idea of rules. So here, we've just got a field where you can drag and drop in objects if you want. So this is how the bark, the leaves on those trees are being assigned out. Very explicit drag and drop from either the viewer or the scene graph. But things get a lot more flexible when you start using rules. Okay, so we'll have another example of this in a minute, but essentially, as you use rules to define and match the names, you can assign the shaders to a wider variety of objects. So, okay, let's take a look at the roof. The roof is set up so that it's looking for world geo // The / means search from everything that point onwards through the full depth of the graph. And you end up with anything that matches then this material underscore roof star. So if we take a look, that means we end up with all the roofs based on their name match. So all the roofs will get the same shader. This is really cool, flexible power. Now you don't have to develop the look of all your assets at one time in one file. But the fact is you can if you wanted to. Okay, so what's happening here is then we branch so that we deal with the specific nature of each of those buildings. We will isolate the one house. We'll set up the camera. And then let's take a look at what we actually get from this. Okay, so we have a house file with the roof. The tiles are running in the wrong direction. Now, depending on where you are in your production, what you can do here is you could send this back and have them fix the geometry. Or what we can do is using the same material node, setting it to an override mode, we can give it the piece of geometry, which happens to be this roof. We can pull from the material the attributes that we want to change. Okay, and we'll show this in action in a minute. And then what you end up with after that point is the roof tiles running in the right direction because we've been able to flip it. Now, the cool part is that you've maintained a history. If I come back up to the roof and I come into here and I really crank down on the diffuse value, even all the way down here, I pick up that change. So the reason why you would want to set up your look development for a city scene like this is if the reason why you would set up everything like this is that if you wanted to actually have one artist touch multiple objects that are going to have a similar art direction, you can do it all from the one project file. That way, as the art director is providing the instructions for what they want done, it's not having to be repeated, it's not having to be shared. The work gets done, and if the art director needs to make a change, then you can work from one place and affect many objects. So that's the power that you get from Katana that you might not get in other situations. Okay, all these things come together, they have a bit of randomization applied, and then we end up here. The main point we want to make here is if we look at the bake node here, what you end up with is you define the root location in terms of where on that model are you going to compare. And then the node itself takes the two inputs, right? You are comparing this point here where you have a gray model to this point here where everything's done. So you tell it where to capture from in terms of that root location, and you're going to pick a point that is not the instanced varying name. In other words, if you're working in a world outside of namespaces, you want it to be the dependable, non-changing portion of the object's hierarchy, or the first point of it. And then you end up comparing those 2 points, and it captures all the differences and it writes it out to this file. All right, so if we pop back into the other file that we were looking at, what we find is on this node here, we have the same idea that we were discussing before, which is we have an expression locating that root node for all these, in this case, house 3, and then we're applying that look to it. Okay, so because we're using an expression, we don't care if the layout changes. We don't care if the art director adds, subtracts, you name it, you're fine. Because they could add 100 more house 3s that all need to have the same setup, and you just basically, will cover them all through this. So crowds, city scenes, cars, you name it, anything where you have massive reuse in a layout, this kind of workflow becomes golden. You can also, of course, be explicit and say this exact piece gets that one look file. But let's look at what the significance of this is, which is none of those models or those shaders are actually in the scene, right? They're all baked into the look file that we looked at. But we do have the option to work on that. So let's take a look at that, because I promised you we'd look at the setup in terms of how you would do one of these overrides. But let's actually sort of multitask and look at it in the context of the look files. So again, I've opened this file very quickly. I've not actually had to look through the scene graph. I've not had to deal with anything in the viewer yet. All the information I need to interact with is here in the nodes, it's in the parameters, and it's in the image. Okay, so we've got our 3D scene. What we're going to do is work in this theoretical idea that one of these particular buildings, the art director wants to change the roof on. We now know that the buildings were divided by their type. They each have their own look file. The look file uses a common shader across the whole lot, right? So if we needed to affect everything, we could go back to that look development file and save out a new look file, version it up, and make the changes, and we'd be fine. What happens when we need to be laser focused? Okay, so let's just stop this render. We don't need it to converge. What we can do is we'll bring up the pixel probe. We will pick a building, and then we can say that we want to select that. So again, it's going to go find that one piece for me. Fine, there it is. Now, one thing that we didn't talk about before is this idea of resolving. So everything in Katana in the node graph as data flows through is fluid. It's not set in stone is the best way I can describe it. All the attributes, all the data is all changeable. You need to, at certain points, the action of rendering kind of freezes things down at that point. There are things like the look files that require a point of translation. So this is what this look file manager is doing in this case. It is providing us the point where Katana says, okay, I will take all the information that you've told me about on the look file assigns, and I'm going to actually kind of process it so that it's ready for you to use. So here we go. I've got this look file manager. I've got this piece of the roof selected. Now, keep in mind, we found it just by picking the image, but what we have is this look file data, right? So this grayed out object means it doesn't come from that exact piece of geometry. It's inherited down. But we do know that this is the look file that carries the information for that piece of geometry. So this is where all the shaders are. So it's cool. We have this tool here that says we want to add the look file. So in the look file manager, I've just added the look file that was referenced here. So what this means now is if I scroll to the bottom and we look at everything from this standpoint down here instead of above, is that we actually have the materials now in the scene. Okay, so I can walk my way through here. So you can see we have materials that come from a look file. There's the look files, there's the actual look file, and then here are those two parents that we said before. So the standard and standard textured. And there we go. So under standard texture is the roof. Cool. So what can I do? Well, in Katana, this tool does have within it, the look file manager that is, has the ability to add a material node that I can use to do an override. It's cool, but it's a little stealth. So it depends on how you want to run, but part of the strength of Katana is this fact that you've got a node graph that functions like a recipe that allows you to annotate the work you're doing like we have here. So what I can do is I can now add in a material node. If I could type, there we go. I can add it in below here, right? I can say that I want to edit that one. Now remember, I'm creating the 3D scene from the bottom. I'm going to change the parameters of this one here. So I'm going to say that this is fix roof. I can set this to an override materials mode. Now what it's done is it's now flipped over to the point where it says, okay, I've got a cell field and I want to know what attributes you want me to fix. Because I've clicked on the material already, let's just sort of cut to the chase. Because I have it here, I can find its parameters. Now these are, again, all the attributes. So they're the read-only sort of derived result, you could say. I'm going to middle mouse button drag up the diffuse value. I'm going to just really throw it down really low. Now I've got to choose what object. So that's pretty simple. I can say that I can either copy this to clipboard or select it. There's no harm in saying select because I've already gone through the process of expanding the scene graph. I can then just say that add that statement. So there we go. I've got the scene location, that being this roof. I've got the change of the exact parameter that I want to make to only that piece. And now I can say, let's take a look at it. Okay, so there we go. So that one piece has now had its one shader with that one override made. But the cool thing is that, again, it's the history. It's the procedural and hierarchical changes. If the art director says, hey, let's make all the roofs blue, someone else goes into the asset file, makes the blue roofs, saves out the new look file, and that gets loaded in the scene, every single roof would turn from blue to pink, but this one would still be darker blue than the other ones because it would have picked up this change. So the lighting, the shading, the scene management all work in this fashion. And that is where the true power lies in terms of Katana and why people are so passionate about their use of it. Okay. So why don't we step out into some more basic files. We'll take a look at some of the details of the materials, the inheritance. We'll look at specifically at some of the cool things that are in the Gaffer 3, and then we'll move to question and answer. All right, thanks, guys. All right, guys. So wanted to talk a bit more about the power of inheritance and this idea of parent and child shaders, and it's a good example of how all of this power kind of flows through Katana. So let's take a quick look at this node graph, and then we'll jump into what's going on. We've got a live render going with these exciting 3 spheres. Right, so first off, we're creating a background very easily. We just make one polyplane, we copy it, we transform it. Pretty simple, straightforward. We make our background that way. Similar fashion, we are taking one sphere, making it a sub D, copying it 2 times, laying it out. So very, you can do all the fun basic fundamentals very simply in Katana. Now we've merged all that scene together, but then we start getting into where things are interesting. So there's one material plot against a background. We now have an interrelated set of shaders. Okay, so we'll start here with this metal. So I've added a Pixar Disney shader, and I've set up just to basically by changing the metallic and a bit of the roughness. Now, what's happening is that the silver shader is the parent, the middle shader is the child of it, and the one on the right here, the shinier blue one, is the child again of this. So we've got 3 levels of hierarchy that allow for inheritance. Now, this is a very simple example, but this could be a rich, complex set of shaders. You could have a complex car material, wood, plastic. The possibilities are that you can define a set of materials, either in a PBR or non-PBR workflow, that allow you to create consistency across your art direction. Allow artists to get started faster because they can have a starting point. So what happens? If I come in and actually change the roughness to, say, 0.1, we can see that the left and the middle update, I've changed the roughness on this one, so it doesn't take any of the updates, but I could also come up to 0.7, and you can see that change doesn't take place. Now, if we come down to blue, good old blue here, it is set up as a child, not a default like this one. So I've overridden, you can tell by the yellow, that I have overridden the color. I'm inheriting the metallic property, and I'm inheriting the change from the default to the roughness. So I could change this and say that, you know what, let's make this more of a foundry yellow. Not quite, but it's a good gold, right? So now this one has inherited the gold color from this one, which has inherited most of its specular properties from this one. So we come down to the shiny gold dude down here, and what I've got is the same idea. So it's inheriting, you can see the colors coming from somewhere else in the chain, same with the metallic properties, but I've overridden the roughness. So I could set this to 0.2, slightly roughen it up, but it's the flow through of the information that makes this all important. So literally, I can come all the way back up to the metal and decide that, you know what, the metallic ratio is not what I want it to be, and so I can adjust all of them in one go. And this just flows all the way through. So this principle of inheriting and changing attributes is fundamental to Katana. It's fundamental to the power that you have with Katana, and it flows through the lighting, the scene management, and the look development. So why don't we go take a look at some of the things that we can do with Cell. So what we have loaded now is a nice example, short and sweet, shows you a few different things. So we're going to cover Cell, querying metadata, and some of the nice things that are unique to Katana in terms of lighting tools, because all the usual things of moving lights, placing lights, aiming lights, all that stuff's there. So we don't need to necessarily spend time covering it. So what have we got here? Teapots, cones, spheres, oh my. Well, let's take a look at the node graph. just colored it up. So we have, we're making a cone, copying it, placing it. We made a teapot, copy it, place it. We have a sphere, copy it, place it. One lonely plane all by itself, camera, and then we start getting into the rest of it. But let's take a look at what we've created there. So at this point in the node graph, what we have is all our geometry, and I've arranged it all so that we have something to look at. Now, what I want to do is talk about CEL for a minute. So CEL stands for Collection Expression Language, but it's so much more than is advertised on the tin. So you have the ability to match by name, match by metadata. You have the ability to collect things like you would with the Maya selection set, but that can be driven by expressions. So you have a whole range of selection power that goes from explicit to dynamic with attributes and completely logic driven. All right. So what I've got here is an attribute set node. So typically you would add extra attributes by Lua attribute scripts, which are Python driven, or you would actually have these loaded by custom mechanisms. And finally, you can put them as extra attributes on in Maya if you are exporting the limits from there. So what I actually did was I just took a smattering of these objects and pulled them in manually. But what I've done here is I've actually said that I want to make a surf color, surf underscore COL attribute, and I've set it to blue. I do the same thing here, different set of objects, say that it is red. So set up my render globals and whatnot. Split my lighting into 3, but we'll talk about that in a minute. Now here we have a gray shader being made, the blue shader, a red shader, all fairly straightforward right now. The gray shader is being assigned at the geometry level, so the geo group on downwards. So it means that anything that is gray is just taking the first level of assignment. Anything that is blue or red is taking an overrided level of assignment somewhere below this geometry level. Okay, so there's 2 methods that we'll look at. One, I want to look at the expression driven. So here, what we're doing is we have // star. So like we said in the earlier segment, // means anything beyond, like it's a search pattern. So it means everything. Search everything in here. So it's matching name first and then attribute later. So right now it means it's trying to search through every object. Now what it's going to do now is it is going to look for the surf underscore COL, so surf color attribute, and it's trying to match against that string being blue. So if it is blue, then this being a material assignment node, it will have its set of instructions and it knows to apply the blue shader. I do the same thing here with the red shader. And what we end up with is an image that looks like this. So there we go. Proof is in the pudding. So blue from the blue attributes that were set, red from the red attributes, gray from everything else. We could add a whole bunch of other things in from Maya. Again, the whole contents of the scene could change if you were bringing things in from either a customized load from an asset management system or Lembic files or USD files. These attributes, if they are what's driving the shader assignment, doesn't matter what you load because you're using the logic to drive the work. So that in itself has nice power. Now you could also get as granular as you could say, okay, match to everything that's a teapot, and then take the teapot shaders that are blue and apply it to the blue objects, and that teapot blue shader could be different than one of the other ones. In this case, we've kept it a fairly simple example. Now another way of doing this. Now we're using the shader assignments as our method to demonstrate this, but what we have inside of Katana is also the idea of a collection. The collection, like I said before, is like the Maya selection set. So here we can create a collection named blue, which is going to be stuffed up at the root level, and it's going to be driven by that same expression that already matched these blue shaders, and is going to create that set or collection and call it blue. We've got another one for the red. Down here, what we have is, instead of assigning by dragging and dropping or by using a expression, we are assigning by the collection. So it means that you can create, if you look at it this way, a template that has large parts of the operation in it that are driven by these collections. And then what you can do is you can set these collections up from a higher level in the node graph, and then have everything feed through those collections. So you can have a one-stop place where you can change what is happening inside of your node graph. So everywhere that would then reference that collection would get those updates. So if you change the parameter expression, or if you merge, you don't necessarily have to have just one of these. You can actually add in a custom, you could add in paths, and you can choose whether you union or whether you difference or intersect these. So you can create complex selections that are driving the node operations within Katana. So it's a lot of powerful flexibility. Okay, so that in itself is kind of the three major parts. So we've got collections, we've got expressions, and we've got the direct selections. So what else can we do in this file? Well, let's take a look at something else that's going on. So in this case, we just had one of the Pixar area lights lighting this whole scene. But let's talk about what happens when we can use something called the master material inside of Katana. Now, this is pretty cool. So lights are described by their transforms and their shader properties. Now, in Katana, what you have the option of doing is creating what we call a master material. So you can come in and you can add a master material like so. All right. You can choose which of the light shaders it's going to be. Okay. In this case, I've chosen the Pixar square light, area light. You know what I mean. Right. So we've got that. Now what's happening? So if we actually now render, we'll notice that we actually are getting a light per surface, right? So if we go down a little bit farther along to here, and we set the live render, and let's look at this state of the scene as well, you can see now that the image that generated that is because we have an area light above every single object. Okay, but what's cool is that inside this rig, so the rigs are just what you expect. They are a locator that you group your lights underneath, that you can export and import these rigs. You can share them without having to do much else. But the cool thing is that all the actual rendering properties, so the intensity, the color, all that is driven by the master material. Okay, so I can come in and say I want to make all these lights red. Too red. All right, so I can make them red. I can make them brighter. Okay. So all these lights are now being driven by that. So what would be a real world usage of this? If you had a scene with lots of street lights, or you had a lot of point lights, any time when you have a lot of lights and the real thing that is different between them is their position and rotation, perfect candidate for master material, because then you have one location that you can drive everything else from. So you want to like really start boosting the intensity. Great. You want to change the color. You have got it covered. But if you need to move one of these lights, then you can absolutely do that. And we're moving this one right here. Right? So I can completely change what's going on with this light. And I can do that on and on and on for all of them. Now, what is even cooler is the fact that I can actually also add in, if again, challenged on the typing front, but if I add in a gaffer 3 and I bring it down into this section here, let's just move this one out of the way, plug this one in here real quick. Take a look at it. I can say that I want to actually show the incoming scene lights, find my rig, and what I can do is I can say that I actually want to adopt one of these for editing. Okay, so I can now say that I want to change this color to yellow. So you see the guy back here is starting to pick up a different color. I can do that through all of these. And again, you got to remember this is translation, rotation, scale, intensity, any parameter that you want to change, you can change it, and only the one that you touch is going to pick up that update, right? So opposing complementary colors there, so that one's going white, and I can take this guy and say that I want to adopt him, and let's just make it a crazy blue back there. Right. So we've got the ability to, in multiple gaffers, stack our edits, which is pretty cool. It means that you can actually isolate changes, isolate light sets. You have many ways in which you can compartmentalize changes or organization of lights. That allows you to share them dynamically if you want to use live groups, or explicitly if you wanted to then just package things up as a rig and then save that out. So that's one option. Finally, let's take a look at one last thing that I'm pretty excited about, which is, in this case, we have a blocker. So everybody's used blockers in their workflow before. So let's take a look at what we get here. This is new to Katana 2.5. We added the support for the render plugins to have blockers within the Katana UI, or the Gaffer 3 UI, I should say. You could always make blockers, or light filters, I should say. But one thing that we added was the ability for them to be here within the Gaffer 3 interface, which means that you've got kind of a one-stop shop for all things lighting. So if I were to mute this light, what we see is we have our lighting set up so that, what if I move this light filter around, we can see that it's changing, and it's basically a volume that we can control color and intensity, and this happens to be the RenderMan 21 light filters, which are cool. Definitely worth taking a look at. Okay. So, as you can see, there are quite a few different options for Katana. Looking at the lights themselves, one thing to keep in mind is constraints within the Gaffer 3 happen on a rig. Right? So if we look at this one here, with this rig at the top, you have the options for enabling the point constraint and the orient constraint. If you want to constrain a light independently, you'll have to go about that a little bit differently. Now, the other part to take into consideration, we've covered all the power of Cell to use expressions, to use sets, collections. All your light linking can also be driven that way. So Cell and the power of it is going to choose what you do your shading assignments with. It's going to choose your light linking. It's going to choose your scene management. And it becomes also, again, drag and drop, expression based or collection based. Anyhow, so that wraps up all the bits and pieces I wanted to show you on the lighting front. Like I said, all the tumble track, dolly, placing lights, all that kind of stuff is all pretty straightforward. These are just the things that are Katana-isms or unique Katana opportunities, as I like to say. And I hope that you will give it a shot. And thank you very much for your time. And I guess at this point, we'll move to question and answer.